This is Jinyao. Today I'll walk you through what our code changed in week 4 compared with week 3. During week 3, we made the collaboration foundation, including workspace, version documents, and the task management. So in week 4, instead of rebuilding the architecture, we focus on one major upgrade, adding end-to-end image support into chat, retrieval, and AI response. So this is week 3 message endpoint. At this stage, the chat follow was mainly designed around text message. And in week 4, we changed the same endpoint so it can accept both text and image fields in one request. This is the backend entry point for multimodal chat. Um, to support this cleanly, we added a new model called message attachment. So images are no longer temporary UI objects. They are now stored as real backend records linked to each message. We also added schema repair for this new table. So teammates can pull the new code and let the database update automatically at startup. Before saving an image, we validate it carefully. We check the image tab, field extension, field size, and then generate a safe store field name. After upload, the image is not only stored, we also send it to a vision model and ask the model to extract description and key facts. This function sends the image to the vision model as the data URL. That allows the model to read the image and return OCR text and structure information. Once the text is extracted, we save it and add it into the vector store. This is the key upgrade. Images are not just displayed, they become searchable knowledge. In week 3, retrieval was mainly built from uploaded PDFs. And in week 4, we extended the vector store so it can include both document chunks and the image extracted text. So now the AI can answer based on screenshots and image, not only PDFs. We also added image deduplication using hashes, so repeat uploads of the same image do not keep routing the vector store. We also changed the rag answer path. Instead of returning only text, the system now checks whether the final answer is actually aligned with the image chunk. This citation result is used here. If the answer sets an image, we attach the original image under the both replies, so the response is easier to verify. This is the Wix3 chat composer. At this point, the chat UI was still centered on text and basic field attachment. And in week 4, we update the composer to support the image upload directly inside chat. We also added an attachment menu, preview support, and image viewing. On the front end, we first introduce a client-side image query called pending chat image. This stores selected images before the message is sent. This function renders preview chips for the selected image, so before sending, the user can see which images are selected and remove any of them if needed. When the user sends the message, we package both text and image together using form data, so the front end sends one unified multimodal request to the backend. After the backend returns the message, this function renders image attachment inside the chat UI. So this is the final front end. So to summarize, week 3 give us the collaboration foundation. Week 4 made that foundation multimodal. Now images can move through the full system, upload, validation, extraction, indexing, retrieval, and AI-supported response. Next, Qianshu Peng will demonstrate the new features added this week for us.
Hello, I'm Qianshu Peng from Group 8, and this is a weekly update for Admit Assist. This week we built one connected feature image support across the entire chat and RAG pipeline. I will walk through it end to end. So first, a small UI change. The composer used to have a button for file here, and we merged the image and file into a single attached button, and it pops up a tiny menu. So file still opens the PDF picker. So that's our existing document flow. And image is the new path I will demo next. So clicking outside close the menu, same as any normal popover. So now let's send the image. I will attach a screenshot of well the UCSD Tier E requirements page to make the difference to the USA PDF we already have. So now the image goes into appending line. We can stage multiple images here. Let's try another. And this is up to 6 images per message. And remove any of them with the delete sign before sending, like this. So now I add a short message and send it. The message renders without the image since we send image in its message. And it will render with image when several messages pass. And now we can see the AI can read the image normally, and it extracts information from the image and summarize the program as I required. So now let's see this in the view of another member. Here, I sign up as the advisor. And we can see the picture here sent by myself, Qianshu, and the reply of the AI assistant. So the message arrives over the WebSocket in real time and image included. So now behind the scenes, the backend just did 3 things. Let's go to the backend. So it saved the image bytes to disk under Upper Workspace Chat Images folder. And it called the vision model to produce a retrieval-friendly text description of the image. The system prompt forces English output and verbatim numbers, so it embeds well. And it added that text as a new chunk in this workspace-based vector store tagged with metadata that says this came from an image. Here's the attachment ID. Yeah. So let's try to re-upload the same image. Let's choose the same image. And I will just send it to AI. Yeah, so it gave me the response. And let's go back to the backend. We can see here we have a message says image hash hit. So we're using extraction, skipping vision call. So we don't rerun the vision model and we don't add a duplicate chunk to the vector store. This will make the vector store full of the same image and become inaccurate. Now, we hash the raw image bytes and use that as the dedupe key. The message and its thumbnail still show up in the chat, like here. Users see what we sent, but the index stays clean. And now let's try the REG retrieval with image citations. Now I will ask AI a question whose answer lives inside the screenshot. Let's try it. So this screenshot is about the requirements of UCSD. And let's say now about answers in text. GRE is not required and this is correct. Also under the answer, we can see the source screenshot attached as an image, exactly the picture the answer came from. And let's go to the backend. We can see the decision to attach that image is gated. See the step R4. So we use a similarity threshold. After the LLM produces its answer, we embed the answer and compare it against every retrieved chunk, here from doc 1 to doc 10. We pick the chunk that is most similar to the actual answer, not the question, and only attach an image if that winning chunk is an image chunk, and its similarity passes a threshold. The threshold is set at 0.4. You can see here the most similar one is doc 1. In the description, things like this. We can see this is the chunk extracted from the image we uploaded. We use the similarity of generated answer to prevent the case that top similar chunk is not really used in the answer and not correctly related to the question. This improves the correctness of AI answer when we ask some questions that is not really related to the image but is quite similar to it. For example, when we ask like the GRE requirement of USC. And that's why the bot doesn't spam unrelated screenshots when the answer wandered off topic. So now let's try another case, a negative case. The AI answer should have no image when the answer is not related to one. Let's have another question. I asked about undergraduate major requirements since this is mentioned in this USSD screenshot. And we want to test if the AI renders the picture when we ask a similar question. And we can see it goes to thinking. As actually nothing is said in the USC PDF we uploaded before. Yeah, so we can see the AI did the correct thing. It does not give an attachment of image here in this question since this is not at things in this image. It replies in text only, no attachment. And the gating logic is in the same. The threshold and source type check keep it clean. So now let's try to upload more than one picture. Let's say this two. And let's ask AI to about the content in these two pictures. And we can see it gives the correct answer, the logo of Viterbi, and a section of UCSD's graduate program requirements. Well, so that's all updates for this week. Image upload in chat, vision OCR into RAG, byte level deduplication so re-uploads don't pollute the index, answer-driven gating that decides what to cite and image back, and a cleaner composer to enter all of it. In future development, we will keep working on web searching image, collaboration system, users with different roles, and better AI performance. Thank you for watching. We are Group 8 and this is the Tech Milestone video for week 4.